Today we will take a look for quality attributes. This is, to my mind, the second part during the working on the designing the project, and that also quite important to understand before we will start work with some patterns. First of all, let's try to understand what it is and what is the definition of data quality, or quality attributes. So the quality attribute is a measure or testable property of a system that is used to indicate how well the system satisfies the needs of its stakeholders. There are different kind of definitions about what it is data quality, but this one is we can say one of the most popular definitions. But we have to use this term quality attributes quite carefully. So this is the measure or testable property of a system. Some of the experts on this area, they actually prefer another one term that sounds as architecture characteristics. In a classical approach, some of the experts, they call it non-functional requirements. Just for your understanding, all of these terms is about just only one single kind of characteristics or attribute, which will describe the system from the non-function perspective. When we start talking about quality attributes, several questions should be arised. The first one, how to express the qualities we want our architecture to provide to the system or system we are building from it. How should we express them? How to achieve these qualities, these architecture characteristics? How to determine the design decision we might make with respect to those qualities? Here you can see one of the most popular examples of quality attributes. For example, it is performance, security, maybe scalability. How these quality attributes can look like. Let's take a look for the example. Yeah, but before this, we can encapsulate these attributes for next categories. First is functional. Second, quality requirements and constraints. I believe that functional will be, you already understand what it means, but so functional requirements are satisfied by including an appropriate set of responsibilities within the design. Here is the use terms responsibilities. Responsibilities for, it's like a generic term that will describe functional that should be delivered. Let's say by another words, what means functional requirement? Functional, it means what the function user can get from your system. In other words, for example, what kind of buttons he can click, what kind of action he can do. If we will take a look from different perspectives, For example, as you know, right now, a lot of systems, they are development in the domain that is not exactly the new one. And previously, similar system was already implemented from functional perspective of view. If we will compare what is the difference from functional perspective of this system, you can notice that there is almost not too big difference between them. Let's take a look for example, let's take a look for some banking system. Previously, for example, banks use a system that was based on applets and so on. But you still, nowadays, most of them, they are on the browsers. Is there any significant difference in actions that perform the banks since that moment? Not so much. If we will compare with systems that, for example, some trading system, does it change significantly? Not too much. But why the developers just implement the new systems during all the time? Because the most of the problem, one of the most of the reasons why we have to change one of the system to another is not functional perspective, is non-functional requirements. It's quality attributes, because the old system maybe have not so good performance, because old system doesn't cover security points from all measures, and so on and so on and so on. So one of the main reason why the new systems, and what is more important, it is quality attributes or so-called architectural characteristics, whatever. We're talking about the same things. So these requirements are satisfied by the structures and behaviors of the architecture. Another point that we have to pay attention, it is constraints. A constraint is a design decision with 0 degrees of freedom. So it's a design decision that already been made. For example, previously there was decision that we will use some programming languages or reuse some existing models or something like this. So all of this, it is constraints that we have to pay attention for them, and we are not able to skip them. You can look at them as external factors. Let's move. There are two main categories of quality attributes. First of all, I want to say that even since now, there is no one strict opinion, one strict rules. How should we determine these quality attributes? How can we divide them? It depends from the resource. Some of the experts in this area, they can identify such quality attributes in one way and divide it in one way. Another experts, they will think and have different approaches. As much as we can take a look, it will be better, because it also will be impairing that, as we discussed previously, it's not enough just only one diagram. Here we can say the same thing. It's not enough just only one point of view. We have to take a look from different. So one of the points that divide these quality attributes is next, that we have two categories. The first is those that describe some property of the system at runtime, such as availability, performance, or usability. Another category, the second, is those that describe some property of the development of the system, such as modifiability. How easy it will be to modify the code? How easy it will be to test the code, testability. Within complex system, quality attributes can never be achieved in isolation. This is one of the key points that it should be in your mind when you are working with this part. The achievement of any one will have an effect, sometimes positive and sometimes negative, to the achievement of others. That's all about trade-offs. Trade-offs between architectural characteristics. It will be quite, not even just hard, maybe sometimes impossible, to combine all of the characteristics in same time. There are dozens of examples in real life. One of them already was mentioned previously. For example, if you're trying to design, for example, let's say the car. Some of the cars, they have good sport ability. They are quite fast, but they're quite low. They have to the ground, so they don't have good off-road abilities. But another one cars is good off-roaders, but they're not so good on racing. And it's hard to combine different attributes during design. You can try to do this, but the risks that generally your product will fail and you won't be achieve any of them, these risks start growing and they become quite higher. What else we can say here? So let's make just some kind of intermediate summary. Functional and general functionality does not determine the architecture. This is just set of required functionality. But what is determined, the final result of the system, it is mostly quality attributes. What else? Let's move forward. There is another opinion that the architecture characteristics meet 3 criteria. This opinion is by Richards and Ford, one of the famous experts in this area. They propose to divide architectural characteristics, quality attributes, non-functional requirements, whatever. It's all about the same, to next things. Specify a non-domain design consideration, influence some structural aspects of the design, and is critical or important to application success. Here, let's try to understand what it is and how should we understand it. For example, here is examples of operational architecture characteristics. Then we will take a look for examples of structural, for example, architecture characteristics. Here is some of them: availability, continuity, performance, recoverability, reliability, robustness, scalability. This is the examples of operational architecture characteristics or operational quality attributes. Availability. It's quite interesting that, look, we have availability and we have reliability. Is there a big difference between them? First of all, let's try to understand what it is. So availability, how long the system will need to be available. Reliability access if the system needs to be fail-safe or if it's mission critical in a way that affects lives. If it fail, will it cost company large sum of money and so on. Some of these quality attributes or characteristics are the most important, and we will try to spend our time for most important quality attributes. It is availability, for example, performance. This is the most critical ones in this part, but there is no strict division between some quality attributes. For example, some of the expert they will say that reliability and availability that's all about the same things. There is no difference. Some of them will say that availability is as a part of reliability. Some of them will highlight reliability. Some of them will work with availability. What is the examples of structural architecture characteristics? Configurability, extensibility, instability. But by the way, you have to mention that all of them have ility. It's almost, you can take one of the characteristics plus add ility and you will have quality attributes. Maintainability, portability, supportability, upgradability. These characteristics, they influence to the structure. So they're all of them. How do you think, is it possible if you will get the task to design the system that will have all of these characteristics in a good way? Will you be able to do this? It's hard to imagine how you will combine all of them. So try to concentrate on the most important. How can you determine which of them is the most important? This is the question that you can raise. That's why previously we will work with the stakeholders. Stakeholders will be one of the input to you to understand which one you have to concentrate more. Another group of characteristic cross-cutting architecture characteristics. This is just as an example: accessibility, authentication, authorization, privacy, security, supportability, usability. To my mind, what is the most important from this list is security and maybe usability. This is one of the key characteristics. So there are different approaches how to divide them, what they are the list. Generally, there is the standard. One of the standard was proposed, which is called ISO 25010. And according to this standard, these characteristics or quality attributes was divided for next: functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. By the way, I don't see the timing limits of Zoom, but I assume that soon it will drop us. Can you please tell me how much time do we have?
5 minutes.
5 minutes, thanks. So here you can see different subcategories like functional completeness, functional correctness, functional appropriateness, time behavior, resource utilization, capacity for the performance efficiency, and so on. For example, for maintainability, modularity, reusability, analyzability, modifiability, testability. Is it the final division between quality attributes, or what can we say about it? I believe that we have to highlight the most important of them and concentrate on some of them. We will not be able to cover all of them, but the most important, we have to start with them. Another one perspective or point is that how you will extract these architectural characteristics from your domain, how you will understand as a person who will design the system to which one you have to concentrate. So identifying the driving architectural characteristics is one of the first steps in creating an architecture or determining the validity of existing architecture. And first of all, you have to collaborate with the problem domain stakeholders to determine what is truly important from the domain perspective for them. Yes, you also have to have some knowledge on this domain to understand what is the more important to particular case, but try to do not rely only on your perspective, only on your vision. You will be designing this person for others stakeholders, and for other stakeholders, it's completely different things can be more important than you can imagine. Talk to them, try to highlight which of the stakeholders have more interest, more power, more involvement into the project, and has more influence into the project, what is important for them. And according to this, you can highlight these architectural, quality attributes. So an architect uncovers architectural characteristics in at least 3 ways by extracting from domain concerns, requirements, and implicit domain knowledge. Implicitly domain knowledge, it means you have to have knowledge in this domain to understand from your side what is more important. But another one, it is from concern and requirements. What means domain concern? When you will work with stakeholders and when you will communicate, they can arise some things, but they are not thinking from perspective of architectural characteristics. They will think about what they are worried. But you will be the person in the middle between stakeholders and development team. And you have to translate what is the expectation of the stakeholders to the development. Here is some tricky table that can help you to in this case. When you will hear that one of the concerns in somewhere during the discussion, that mergers and acquisitions. So you have to understand that from your perspective, you have to work with interoperability, scalability, adaptability, extensibility. If you will see some points like time to market, for us, it is quite important to go to the market as fast as possible. What it means to the design of the system. That means that you have to concentrate on agility, testability, deployability. If you will hear something from the stakeholders, and they will highlight it that they are quite important, that user satisfaction, then it means what important for user satisfaction from perspective of architectural characteristic. It is performance, availability, fault tolerance, testability, deployability,